right, we're going to be looking at the formula for a geometric sequence, or one of the formulas for a geometric sequence. This is typically called the explicit formula, but the formula for a geometric sequence is f of n in this case instead of f of x. We want to replace the x with an n because we're using n as our exponent for the number that we're looking for. We have a, we have r, and then we have n minus 1. So the function is found by taking a times r to the n minus 1. So to identify what each of those are, a is the first term in the sequence. So the very first term in any sequence, or in the sequence that we're speaking of, that's going to be our a. So the number that we write there is going to be the very first number in the sequence. The r is called the common ratio. Okay, that's the amount that we multiply by. So the r is the common ratio, or what we're multiplying by. So if every number in the sequence doubles, then the r will be 2. If every number in the sequence triples or quadruples, that's what we're looking for there. And then n stands for the number that we're looking for. So that's the specific number in the pattern. So that's our number in the pattern that we're looking for. So what we want to do here is we want to come down to our table here. We've got a set of sequences, and it's going to be our job to find the a, the r, and then the rule, and then we're going to look for two specific terms, the 8th and the 10th term. All right, so when we do that, in this case, our a is again going to be the first number. So in this first sequence, the a would be this -2 right here. And then we want to look at the numbers in the sequence, -2 to +4 to -8 to +16. So to get from -2 to 4, I would multiply by a -2. And then 4 times -2 is -8. -8 times -2 is +16. Now to write our rule, we're going to say f of n equals -2 times -2 to the n minus 1. All right, and then when we go over here to find the 8th term, it's -2 times -2, and then it's to the 8 minus 1, or the 7th power. And then the answer to that would be 256. Okay, we would do the same process to find the 10th term. So we would say -2 times -2 to the 10 minus 1. And that would give us 1,024. If you're at home and you don't have access to a TI Inspire calculator, you can go to desmos.com/scientific. That'll give you access to a scientific calculator where you have access to the exponents. It'll make your calculations a lot easier to do. All right, let's look at the second one. Again, we're looking at the first term. So my first term is 2. To go from 2 to 6, 6 to 18, 18 to 54, I'm multiplying by 3. So again, my rule would be f of n equals 2 times 3 to the n minus 1. So if I were doing that for my 8th term, it would be 2 times 3 to the 8 minus 1. That would give me 4,374. Right, I would do it again for the 10th term. That would give me 39,366. All right, going to the third one. My first term again is my A, that's -1. Going from -1 to -2, -2 to -4, -4 to -8, I am doubling what I had before. So multiplying by 2 to get the next term in the sequence. So again, f of n equals a -1 times 2 to the n minus 1. So -1 times 2 to the 8 minus 1 be a -128. And then I would do the same thing on the next one. -1 times 2 to the 10 minus 1 . And that would give me a -512. All right, I want you to take some time to finish out the rest of this page. If you need to find the next term or need to find what the common ratio is, you can take the second term divided by the first term, and that'll give you the common ratio. So you can take 20 divided by 100, that's going to give you 1/5. So your common ratio would be 1/5, which is the same as dividing by 5. So to get your common ratio, take the second term divided by the first term, and then you can always check to make sure it's correct by doing the third term divided by the second term to make sure that's consistent.